Hello friends, today this experiment is not a experiment that I can show it to you because I done this experiment in a different place, but I did have a video that I captured about it, so I will show it to you with this. And what this topic is about is called a Stirling engine. Now you'll be wondering, what's a Stirling engine? So here's a video of me with some other parents that I have. It was at my uncle's house, and what we do is we assembled it together. And as you see here, when we give that wheel a little nudge, it starts spinning, and it gets faster and faster and faster, as you see. But I have another captured video that goes super fast. You don't even know how much it's going. And all it is just a little flame that you see right there at the right side. And you may be wondering, I don't know what I said, how is it working? So first, let us talk about what's the Stirling engine. So the Stirling engine was created by a person named Robert Stirling, and also he had a brother. So they were the Stirling brothers that created this machine. So their intelligence of this machine is that they just have two pistons that create this spinning motion, and it goes faster and faster if they had a heat source, which can be anything like a sun, it can be a hot liquid, it can be also the flame that we did. So what actually happens is that there are two pistons. These are two types: the displacer and the power piston. The displacer is the big one. What it does is that when there's a heat source that's on the bottom or anywhere, it can either make the atmosphere, it can make the, what do you say? You can say make the air expand, let's say. The air expanding means the air pressure will rise up more. So it increases, and that's why it moves up. But they also have a cool plate. And the cool plate is from the room temperature. And that room temperature makes that plating on the top cool. So what it'll do is decrease the decrease the air pressure. And that's where it'll go down. But how can it go down if you don't have some sort of like a fluid that will push it down? That's impossible without that, right? That's where the power piston comes. It's literally like a syringe. A syringe, what you do is you push that fluid out, or water, because there's water inside, and you have a little bit of air inside. And that air, when you push it down, that air is pushing that water, and thus it goes out. It's literally just the same thing as this. The power piston takes that heat, because here, first of all, in this this animation, as you see here, there's like a little gap between it, and that heat can go up and go through and go up. It doesn't have to be at the cooling place, the cool plating, not the cooling place. Sorry, grammar. The cool plating, it actually can go to the power piston, and it also lifts that, because we said that the heat makes the air expand more. So that when that air expands, not air temperature, I was about to say air temperature, air pressure increases, and thus both pistons will be going up. But when it cools down, because the pressure on the the heat going to the power piston is gonna cool off more than the heat with the displacer piston. So that's why the power piston air will cool down, and then it will decrease the air temperature again. Air pressure. It'll decrease, and thus it will suck down, or not suck down. It will press down, and the power piston will press down that fluid and will move that displacer down also when the heat is cooled down. So that's why if something is cooled, you need some energy to push that down, and that's the power piston is needed. The heat source is has sufficient enough of energy to push it up. So that's fine. It's when the cool plating there's less energy. Because think about it. If you have hot air inside, there's more kinetic energy than the cool air. Because it decreases that kinetic energy, and thus it doesn't give that much energy to the displacer, and it doesn't move. So that's why you have that power piston, like I said. So I hope you enjoyed this very brief description or exclamation, anything you say, about the Stirling engine. Because this is a very interesting engine that I ever seen in my life. I didn't know about it, so this was very interesting. And I tried to research about it, and it was really cool. So I hope you enjoyed it, and I'll see you next time. Bye!